Let me conclude this course by mentioning some applications of measure theory within mathematics and even outside mathematics. So, first let's discuss some applications within mathematics of measure theory. So, we have a few applications in functional analysis. This is the study of Banach spaces and Hilbert spaces. Banach spaces and Hilbert spaces, as well as operators on such spaces. So, we have already seen that our space of L1 functions is in fact a Banach space, and if you go higher, L2 functions become the space of L2 functions becomes a Hilbert space, and higher LP spaces are in fact again Banach spaces. And it's quite a vast theory in itself, and it has as its basis measure theory. So that's one application of measure theory. Another application is in harmonic analysis. So here this is about a generalization of Fourier transforms there exists some notion of Haar measure on groups, which is a measure which is invariant under some group actions. So here Haar measures are used fundamentally for studying the generalization of Fourier transforms in such a setting. Yet another application is in ergodic theory, and this is about the theory of dynamical systems, So a behavior of a system when it evolves over time. Okay, so ergodic theory gives you some quantitative results of how a system behaves when it is allowed to evolve over a large amount of time. So this is about the qualitative as well as quantitative behavior of systems that evolve in time. So this is about ergodic theory, and especially what we have done in the last week's content, namely the Hardy-Littlewood maximal functions are used quite often in ergodic theory. And last but certainly not the least, there are many applications in probability theory, and probability theory, as we have already seen, as you might have already seen in your high school or in other subjects, it is quite useful even outside mathematics. And the basis of probability theory can be seen as a measure theory background. And here of course one deals with especially with stochastic processes, which are extremely useful in modeling real world phenomena. For example, Brownian motion that happens in a dissemination of a gas or a fluid. In physics, this is modeled using stochastic processes. So in fact, probability theory is perhaps the most important application of measure theory, which also applies outside mathematics. So we will see just now the applications outside mathematics, but even within the mathematical applications of probability theory, of course we have the measure theory as a fundamental platform for building up the theory of probability. Okay, so this is about applications within mathematics. Let's see some applications outside mathematics. So first is in physics, second one is in economics and finance, and third was in machine learning. And like I have just said, all three use heavily the theory of probability. So one could say that you may not need to know very in detail or in depth measure theoretic concepts to apply probability theory to physics or any of the other subjects, but one should know that in the background, as a fundamental platform, all these theories rest on measure theoretic concepts fundamentally. So even though probability theory can be applied in physics, economics or machine learning without knowing measure theory, but still it's helpful to know that in the background there are measure theoretic concepts. So probability theory is probably the most important application of measure theory outside mathematics. On the other hand, you also have for physics and maybe also in chemistry, because it's related to quantum physics, the application of functional analysis, because so this is especially true for quantum physics, because the foundations of quantum physics, the mathematical foundations, rest on functional analysis and especially on the formalism of Hilbert spaces. So these are just some few applications of measure theory outside of mathematics. So this brings us to a close for our measure theory course. I hope you have enjoyed it, and I thank you on behalf of the entire NPTEL team for following this course and completing this course, and I wish you the best of luck for your exams and for the future, and I hope that you will be able to apply these techniques in whichever subjects that you are interested in and whichever problems that you are challenged with. Thank you.